Hi everyone. Today we will be learning about part 2 of the patterns and series lesson. This is to highlight that logic is also a visual art, which means that our eyes is linked to our brain, and when the message from the eyes is sent to the brain is able to recall what it understands as a visual form or rendition of logic. So that will tell us that we can relax about understanding number series, as simply a matter of letting the eyes work with our brains so that the pattern recognition can become simply an exercise in the appreciation of beauty. Okay, let's look at this example where we need to find the next item in the series 2, 7, 18, 35, 58, and then we can go for the next one or the next two items in the series. So if we need to go from 2 to 7, that means we need to add 5 to 2 to go to 7. To go from 7 to 18, we will have to add 11 to 7, and then we go up to 18. From 18 to 35, we need to add up 17 to 18. And from 35 to 58, we need to add to 35, 23. And then so we ask ourselves, what should be added up to 58 to go to the next series? But then we need to recognize that from 5 to 11, we go up by 6. From 11 to 17, we go up by 6. From 17 to 23, we go up by 6. And from 23 to the next, we need to go up by 6, so that what should be added to 58 must be 29. And 58 plus 29 will give us the answer of 87. And then from 87 to the next term, we will have to add 229 as 6, making the difference from 87 to the next term to be equal to 35, which tells us that 87 plus 35 becomes 112. So the next two terms in the given series will be 87 and 112. So that makes it clear. For the next example, this will be a series of letters. So we go from D, G, K, P, and V, and then we need to look for the next term in there. So for those of you who are not so used to recognizing this as a series, then we need to just recall what's the natural sequence of the letters in the English alphabet. And so we just recognize that as a natural rendition of how the eyes recognizes the sequence of the letters. And we are taught to understand this sequence as early as in kinder or grade 1. But now that we are in freshman year, in the tertiary level, our eyes have enough exercise of recognizing this pattern. So let's just mark where these letters are coming from. So we go from D, we move up to G, from G to K, and from K to P, and from P to V. And so let's look at the skipping. So from D to G, we skip 2 letters. From G to K, we skip 3. From K to P, we skipped 4. And from P to V, we skipped 5. Therefore, the next term, we will have to skip 2, 3, 4, 5, and so the skipping will be a 6. Now recognize that from V, we need to count 1, 2, 3, 4, and then we iterate. The Z goes back to A and then a B. So what will be the skipping 1, 2, 3, 4, 5, 6, and then therefore the next one will be a C. So the next term in here will be a C. So what would be the second item of the second blank in the series? So when we skip 6 from C, we're going to skip 7. So we count 1, 1, 2, 3, 4, 5, 6, 7. So the next term that we're going to have in the series will be a K. So clear enough? So we need to understand that the letters in the English alphabet can build up for us a unique number system when we make a correspondence for the letters A to Z with the values 1 to 26, and then when we go up after 26 we just iterate. Okay, for this next example of a series, we recognize that all the numerators are ones. So with that, that tells us that we need to concentrate on the denominators. Okay, so let's look at the denominators in there. So we know that the next term that we're looking for will have a 1 in the numerator. But the denominators will be 2, 6, 18, 54, and 162. So what is happening in here? From 2 to go up to 6, we need to multiply 2 by 3. To go up from 6 to 18, we need to multiply 6 with a 3. From 18 to go up to 54, we need to multiply that with 3, sorry. And from 54 to 162, we need to multiply 54 by 3. So without having to sweat out, the next term will tell us that we need to multiply 162 by 3. And so that gives us 2 times 3 is a 6, 6 times 3 is an 18, carry 1. That will give us the value in this as 486 in the denominator. So the next item in the series will be 1 over 486. For this example, that tells us that when we know that the pattern is so defined and is so fixed, we don't have to look at the numerator and look for other values other than 1, as it is plainly demonstrated by the series. For our next term, okay, we just need to relax. We go from 144 to 90 to 120 to 82 to 96, 74 to 72. If you don't get to recognize that there seems to be a skipping pattern in here. From 144 we go to 120, then to 96, and then 72, and then this. Okay. The second skipping will be from 90, we go down to 82, from 82 to 74, and then that missing value. So when we go for the first set, so to go from 144 to 120, that means we minus from 144.24 to go up to 120. From 120 to 96, we need to also subtract 24. So from 96 to go down to 72, that also means that we need to subtract from 96.24. And then from 72, that means we need to subtract from 70 to 24. And so what will we have? We have 8 and then 4. Okay, so 72 minus 24 will give us 48. Now, to go for the next set, We go from 90 to 82, that's a minus 8. From 82 to 74, that's a minus 8. And from 74 to the missing value, that's a minus 8. So 74 minus 8 will give us a value of 66. So the missing values in the given series will be 66 and 48. Now let's learn how to recognize patterns just looking at figures. So we don't have to go to school to recognize that these are just figures which as children we can draw. Okay, so for the first set of boxes, we're just using triangles and the L-shaped figure and then circle. That's all we have in the boxes. So we will have to recognize what's happening to this figure. So let's first trace what's happening to the triangles and the circles. So what happens from the first to the second box is that the triangle drops down and then it acquires a partner figure, a second figure. So the triangle drops down and then it acquires a circle. From the second to the third, what happens is that it goes diagonal and then the placement of the triangle and the circle reverses. So the triangle moves to the rightmost. Okay? And then from the third to the fourth, it again drops. Anytime it drops, it changes the set of figures. So from circle to and triangle to two circles. So for the last box, we know that the two circles will move diagonally. And then that this two will be shaped as two circles, okay, at the top leftmost corner. So there will be two circles in there. And then because the two figures must change places, but because they are both circles, we wouldn't know the difference in the exchange of the position. So it will be two open circles. And then what happens now to the L-shaped figure? So what happens to the L-shaped figure is it's down and then up, okay, up on the right, down again, and up on the left, and so it will go down. But for the L-shaped figure, we will have to figure out where the smaller portion will stick out of. So will it be on the left or the right? So we have left in the first, right on the second, and so on the fifth, the small thing will be on the left. So the shape of the figures for the last box will be two circles on the upper left and then the L-shaped figure at the bottom with the smaller end on the left. Okay. For the second set of boxes, we have just these very simple sticks and circles at the end of each of the sticks. And then we need to recognize that we have the pattern 3, 2, 3, 2. So for the fifth box, we will have to have three figures. So let's just work with the three figures. What's happening with the three figures? To go from the first to the third, what happens will be that the third and the second moves towards the first and the second. Okay, so this two, okay, moved from the third and second position to the second and first position. Okay, the third is maintained as a stick with an upper open circle, and the first, which was the second in the first box, acquires an open circle, but we have the position maintained. And then the third figure will be the first figure, but it flipped down with the shaded circle now at the bottom, when in the first box it was at the top. So what happens with the third? The third and second will move up to the second and first position. Okay, so we will maintain the third as a stick with a closed circular object on the bottom. Okay, so that is what we have. And then the first will be, the first will be the second, but it will now have, instead of the open, instead of the open circle on top, it will now have a closed tip, circular tip. And then the first object or figure in the third box now becomes the third figure, and now it will flip. So for the third box, we have the tip at the bottom. For the third, we will have the open circular tip on top. Okay, so this is how the missing figures on the fifth box will look like. So the first stick will have the circular closed circle on top. The second figure will be upside down with the closed circle at the bottom, and the third figure will be a stick with an open circle on top. Okay, for the third figure, what is happening in here? So we look at the tips first. That is at the bottom, and then it flips. Okay, so how much type of turning do we make on the triangle? Okay, just looking at the shaded tips. Okay, so what we do is, from the bottom it moves up, and then it moves down like on a circular motion, okay, like a clock. So clockwise, and then from in here it moves clockwise, and then it goes down like so. So with respect to how much kind of turning do we make, so we recognize that this will be the entire, from like a position from 6 o'clock to 12 o'clock to 3 o'clock, and then 6 o'clock again. And so it will again go by how much form of twisting. So again, the tip of the triangle will have the shading like so, like that. But then we again concentrate on how the figure in the middle will behave. So this one flips, okay, and then so it flips, okay, and then now it again flips back to its original position, and then it flips towards the bottom. Okay, so if in the fourth flipping it will be at the bottom, okay, and therefore for the third one it will flip, it will flip. So let me just make that a little bit bigger, so the shading will be at this tip, okay, and then what happens to the middle portion? So when it's upright, no, we go, this one flips on the reverse, okay, and then we flip it back, and for the fourth it now flips downwards. It's like shifting this. If you would like to check on, it's like turning it so that the shaded portion will be at the bottom. So that's the turning from 12. If you try to simulate it like a clock, and then again you can flip that, it flips from the 12 o'clock position of the shaded portion of this middle figure to the 6 o'clock position, and then, okay, if you shift this one, it will flip. So the position for this would be that it will look like, okay, so you will have to shift it from 6 o'clock to 12 o'clock position with the shaded portion in there, and so it could look like so, okay, or it could look like the middle figure could look like that. So there are two possibilities, okay. So I hope that we have shown how the visual recognition of logic can become a tool for sharpening our minds and providing reason to what we think must be the approximated behavior of something which traces some historical footprints. So, ito, di ba, when you render art as an abstract form of communication, then it's just using codes to let us know what possibly will be the next set of statements. So this is where we end our short discussion on series using number series, okay, and then the English alphabet, and then the series that's used for abstract reasoning just using figures. Okay, I hope that this has somehow introduced you to the world of logic, which does not all the time use numbers. Okay, so if you like this discussion, let us know by liking or subscribing or putting your comments down below. Thank you very much for your kind attention. See you next time.